This is Møller Nielsen from Java Code Geeks, and I'm going to teach you how to apply high availability to your Docker container by using Docker Swarm. If you have an image with an application that you want high availability for, then Docker Swarm could be the solution for you. Now, additional to this video, there will be a related article in the description below. Please take the time to like, subscribe, and hit that notification bell so you know when we have more videos coming up. Now, without any further ado, let's get started. Up and down like Kubernetes can, but it is very simple and it's very easy to use since it is part of the default Docker installation. So that means that you can actually just create a Docker manager, and then you can have nodes. You can have workers actually joining this Docker cluster, and you can also have workers going out of the cluster in a very dynamic fashion. But you have to add these workers by yourself, and you also have to remove them yourself, and you also have to scale up and down by yourself. In Kubernetes, you would use something called the horizontal pod autoscaler that would automatically scale up and down when the CPU or memory usage reaches a threshold. You do not have the same possibility with Docker Swarm. So Docker Swarm is for someone that does not want to spend the time that it actually takes to actually use to know about the Kubernetes features, because Kubernetes has a lot of features and the learning curve is a bit steep. There's a lot of concepts to keep track of. While if you know about Docker, then the next natural step would actually know to get some knowledge about Docker Swarm, especially if you know about Docker Compose, because then it's very, very easy to apply high availability, and that is the purpose of the Docker Swarm, of course, and also for a Kubernetes cluster. That is to ensure that we have high availability, and if one machine goes down, then you still have your application running on other workers, and then those can actually take over because we have a load balancer in front. But let us try to look at the flow as we have right here. The first thing that we need to have is a Docker manager, and the manager is actually also a worker by itself. And the manager becomes a manager by just writing Docker Swarm init, and then you have a swarm. So it's actually that easy. After the manager has created the swarm, then another worker, which means another machine, it can just be another virtual machine, can then join the swarm by writing Docker Swarm join, and then you can join the swarm like that, and then the manager automatically has this node where he will or it will actually distribute application to as well as itself. So manager is also a worker. And of course, a worker is a worker, and a worker is just a place where Docker images can run as Docker containers. Along with the Docker Swarm, if you want to take one of the workers and then just run a Docker container on one of those without being inside the swarm, then that is totally supported. It will just not be a part of the swarm, and it will just run on the same worker host as the swarm will. That is totally fine. So you can actually install and run Docker containers on each of the workers. Then we have something called the ingress load balancer. So that means that when a browser actually targets the manager, and that is the purpose with this is actually to target the manager, because then the ingress load balancer will then load balance the traffic to one of the workers. It could be the manager, since it's also a worker, so it could be the manager that gets the traffic, but it could also be one of the workers. And then let's say that you are trying to reach port 8080, then of course it will be port 8080 on the manager or on the worker that would actually be reached. And the default strategy is actually round robin, which means that if you make two requests, then the second request will go to if the first request went to the manager, then the second request will go to the worker. This can also give us issues if we're trying to have a security setup where we have some sessions that is known only by memory. Then we have a problem, because then the session will only be known for instance, the manager, and then the next request, where the session is a part of the cookie header, is actually not known by the worker. So just keep this in mind, that when you are dealing with the Docker Swarm, you need to have a security setup that actually allows this. So we are not using security for this setup tonight that we are having right here. And to begin with, I'm going to use my own machine, and then I'm going to use Docker Playground. If you have not tried Docker Playground yet, then this is a cool opportunity to actually use Docker Playground to get some experience and get some knowledge with Docker without ruining your own machine and without paying for multiple virtual machines out in the cloud. There's another thing we need to talk about, that is a Docker registry. There needs to be a Docker registry available for the manager, and as long as it's available for the manager, then the manager will actually ensure that the workers also can access the Docker images. So we have a Docker image that can be pushed up to this Docker registry that we have right here. And in this situation, it's my HTTP application image that I have just pushed right here. And after I pushed it, then I can deploy my stack to the swarm. And then, depending on how many replicas I have requested, then it will be spread among multiple workers. If you have, you can have a setup where you just have one replica of an application, and then of course it would not be spread among the workers. Then it would just be on one of the workers. So this is the theory. It is, as you can see right here, it is quite simple, and it is also very, very simple to set up. So let's get started right away. I have prepared two things. I've prepared a Docker Compose file, and I'm not using my own application image right here. We are going to focus on the Docker Swarm part. So that means I'm going to use two images that already exist on Docker Hub. That means that my registry, the Docker registry that I pointed to right here, the black registry right here, that will be Docker Hub. I'm going to show you how to add your own custom registry anyway, but we're not going to use it. We're going to use fixed images that already exist on Docker Hub. So let us go back. So I have one Docker Compose file right here, and you might already have noticed that we have something that is a bit new. That is the deploy. This is the deploy section of the YAML file right here. Here we can actually say how many replicas that we want up and running at the same time. And I've said I want 10 Postgres databases right here, and they all use the password example. And of course, the user is Postgres. That is the default username. Then we have the admin users interface right here, and I only have one replica of that, and that is on purpose, because if I had more replicas than one right here, then the security setup with the admin interface is not meant for being in a cluster. That means that if you log in first on one of the instances, then the next instance will then not recognize that you are trying to look into the database and to the tables afterwards. Yeah. So when we have these instances right here, they don't have a volume share or anything like that. That is of course also something that you need to take into account. You need to make sure that your application is actually prepared for being inside a cluster. Because usually when we just spin up one instance, then we know that we can volume map some files inside the container, and then it will just run because it has full control over those files. But what if we have 10 instances that writes and reads into the same files? Will that be a good thing? Probably not. So that is why you need to, of course, set up your application to be inside a cluster. And each application usually has its own way of handling the cluster setup. But it is something to be mindful about. To begin with, right now, I'm going to set each replica to 1, because we are just going to train and register the Docker Swarm parts right here. I'm going to expose port 8080, so that means that I want to access my admin interface right here. And that is actually it. Then I have a nice README file right here where we can see what we are going through. So this is the recipe for this video. We're going to create a swarm. We're going to create the swarm manager. We're going to create the nodes on Docker Playground, not on my own machine, because of course I only have one machine. First, we're going to do this on my own machine, and then we're going to Docker Playground afterwards. Then we're going to create the registry from where the nodes can pull images. I'm just going to show you how it is done. We're not going to actually use it. then we are going to deploy a stack from this Docker Compose file that you just saw. And this is the cool part, because this is where we actually get our application and service installed inside the swarm. When we are dealing with a Docker swarm, then you would most likely hear the word services more than you would hear container. So that means that we will be more interested in services than we will be interested in containers when we are dealing with Docker swarms. Then we want to scale up the number of instances, and this is done on the service level. So this is on service level right here. And then when we are done, then we want to remove this. We are going to remove the stack again, and we are going to sign out of the Docker. We're going to leave the Docker swarm first. Yeah. So and this is again something we're going to do on Docker Playground. If you want to check whether your current Docker engine is part of a swarm, then there is a good trick that I will just show you to begin with. Right here, we have this Docker info. Then you can grep for the swarm part. If it says inactive, then your Docker engine is not part of a swarm. So let us just do that. We'll write Docker info, and then we will look for swarm, and it is inactive right now. You might be interested. Okay, what kind of information could I get if I just write Docker info? Why don't you just write that? That's because we get all of these information right here. Get a lot of how many CPUs do we have, and a lot of cool information. But we were only interested in the swarm part, so that is why we look for that. So now let us get started. Right, Docker swarm init. Let us see what happens. Now my Docker engine on my machine right here is a manager. That means that other workers can join the swarm by writing this command right here. And as you can see right here, there's a security token that needs to be given to the manager to prove that this is actually allowed to join this swarm. So you could think of a situation where you have Docker workers that wanted to leech in and get in applications. Then they are not allowed, then they can actually not do that because they do not have token right here. So, and this is then the IP address and the port that is used right here. So this is my manager right here. So let us just run the Docker info again to see what happens now. If I grep for swarm, now the swarm is active. Swarm is active. That is pretty cool. That is pretty cool. So now we can create the registry. So I'm going to create a service, Docker service create, and then we're going to name it registry. We're going to publish, and we're going to publish it, and we're going to use the image that is named registry, and then 2 right here. This is just the tag. So the tag is just the. So this is actually a registry that is available on Docker Hub, and of course it can also be used to other purposes than for the Docker swarm. It can also just be used for your own internal registry. But let us just run that, and let's see what happens right now. So now we have a service that we are creating, and here we can see that is the. This is the Docker container, and this is the service. So if you want to list the services, then you can write Docker service ls. Then we get a list of the services. And here we can see it has a name and it has a number of replicas. There's only one replica. There's only one instance of this registry right here. We're exposing port 5000 for this registry right here. So long, so good. Now let us try to actually deploy the Docker Compose file that we have, and then we need to give a stack name, and I'm going to name this Mike's stack demo. So let's do that. Docker stack deploy compose file Docker compose.yml, and then Mike's stack demo. Let's see what happens. So now we created first. We got a network. So this is a network for. This is just underscore default. This is a default network for both of the services. That means that then they can actually see each other. That means that the admin interface can see the database. Can see the database through these names right here, through the service names. So we should always mention, we should also use the service names when you try to communicate between Docker applications. So yeah, do not use the container name, but we should use the service name. Let us see what actually happens now. We have a command right here that says Docker stack services, and that I can mention. Let's try again. So, copy Docker stack services, and then my stack demo like this. Here I can see now I have two services running. I have this admin right here, and I have this Mike's demo DB running right here. And there's only one replica of each of these. Of course, we can scale it up. So that means that we can mention a service, and then we can say scale it to something. So that means that right, Docker scale service, then and then Mike stack demo, and then underscore DB equals to 3, and then we are so it was the other way around. Service scale like this. Now I'm scaling up my my service named my stack demo underscore DB. This is actually the Postgres database itself that we are now creating 3 instances of. Let us again try to list our stack. So a stack is just that is an application stack, as it actually says. That means that you could actually inside your Docker Swarm, then you could actually deal with multiple stacks. That means you could have multiple application running inside your swarm. It would make sense because now you have these nodes that you have these workers already set up. Why not deploy multiple stacks inside them? Because we have this grouping of them that says stack right here, so we can say Docker stack plus, and then I can list my stacks right here. And I can also see how many services this that my stack actually contains. I can also write service plus services my service ls like this, and here we can see the services, and we can see which we can see which service, and we can see how many replicas we have. There's another one that is the Docker node ls. Here I can see which node which node is doing what, and here we can actually see that we have only one node right here. That is my Docker desktop right here, and that is the leader. It's not a worker, it's the leader. It's also a worker, but it is the leader. This is what actually decides where the traffic should be routed, and also what decides which workers should have how many replicas running. Also write Docker PS. Of course, then we get the list, and here we can see right now we have three databases right here. See the named underscore DB right here, so we have 3 Postgres instances running right there, and then we have the registry running here, and we have the admin interface running right there. If you don't know what the admin interface is, then let me just write localhost and then port 8080. This is the admin interface. So this means that if you have never tried the admin interface along with MySQL before, then you should definitely try it. Example, that's the password. And here we have access to the database right here. So let us try to play with the Docker playground. Okay, let us first try to leave the. Let us try to tear it all down again. Let us try to leave, and let us try to destroy the swarm. We do that by writing Docker swarm and then leave. And now I'll get an error because this is the last manager. So then Docker will complain and will say, if you remove the last manager, then you erase then your whole swarm is actually gone. But you can do it if you want to by writing --force or just -f. This. Then the Docker swarm has been taken down. We can also see that all of our all of our containers actually have stopped. And let us write docker config just for fun, and then we will grep after swarm again. Docker info, sorry. Docker info, and then we grep for swarm, and now the swarm is inactive. This is quite cool, but of course now we want to try to play with some workers, and we want to see that we can actually have multiple nodes. Try to go to labs, play with docker.com if you haven't done it already. It is a cool and free service where we can actually learn how to use Docker. Also, if you don't want to use Docker Swarm, if you just want to play around with a normal Docker application, or if you want to play around with your own application, then you can actually also do that. You can see here right now I have a session for 4 hours. That means that after 4 hours, my the instances that I'm creating right now, then they will be stopped. But that's fine. I just need this for demo purposes, and I'm using this to get a feeling of what Docker Swarm is. So that is totally fine. That I just have these temporary virtual machines right here. It's much better than me having to go out and buy 3 virtual machines temporarily. So first of all, we're going to decide which node should actually be managed. I'm going to choose node 1, which has the IP address of 13. And now we're going to write Docker Swarm init, and we are going to see something funny right here, because these nodes, they actually have more than one network interface. So that means that we have to say which network interface it should be that we want the swarm to work on. And in this situation right here, we want to work on the 192 address, because then the other nodes can then reach this manager right here. So let us write that again, Docker Swarm init, and then we write --advertise address. This means choose the network adapter that we want the swarm to run on, and we're going to choose this IP address right here. And then we get this line right here. And now this is a thing that's a little bit bad. This is because this is a console running inside a browser, so I actually have to, in order to run this command right here, then I actually have to inspect this part right here, and I have to find it over here, and then I have to double click, and I have to copy it. Double click, Control C, and then there's another part actually. So there are 2 parts. The first part, I'm going to the second node right now. I'm going to paste the first part, and then we need to go and get the second part, which is this part right here. Control C. Then we're going to add that right there. Control Shift E. So now we're running Docker Swarm join, and then we give the token, and then we say that we want to join this IP address right here. And the default port is 2377. Enter. Let us see what actually happens. So this node joined as a worker. Okay, cool. So let us just do the same for. Let's just do the same for the last node right here. I'm going to paste the second part first, and then we're going to get the first part right there. Paste that like this. And now the other node has also joined the swarm as a worker. Okay, so let us go to our manager right now. And then we want to write Docker Swarm node ls. So now we can list all of the nodes. Docker, we just need to write Docker node ls. We do not need to write Docker Swarm in front. I think the commands can be a bit confusing sometimes, because we have swarm, we have stack, we have service, and we have node. And whenever you write, whenever you want to list something, then you need to know which keyword that you need to mention first. And when you want to scale, then it's on the service. This is a service that we are scaling. So then you write Docker service, and then scale, and then the name of the service equal to the number of replicas that we want running. It's just, yeah, that is just the thing. But right now we need our Docker compose file. We do not have a Docker compose file, so let's just create one, Docker compose.yml. So, and then I will go to steal it from my local machine right here. And just for fun, let us just start with, we want 10 admin interfaces right here. I'm going to copy this right here, copy, and we're going to paste it over here. And we're going to save it, and then we're going to apply it with this command here. Docker stack deploy. So we're going to deploy it, the compose file, and we can, of course, we can just name it something else if you want to. But right now, the name is like stack demo, like this. So enter. Let's see what happens now. Now we start up all of our applications right there. We can say Docker swarm, Docker stack ls first. So this is the stacks. We have one stack with 2 services and services. Oh, then we need to mention the stack. Yeah. So if we want the services, then we always need to mention which stack it is that we want the services for. So we need to write mic stack demo like this. And here we get the services. Here we can see that we have 0 replicas right now. That is because it is because it's starting up and it's because it's running. And how can we see that it's actually running? But of course, we need some. We need a little bit of patience, but we can also see if we run this command again. At some point, then we will see that. Then we will see that the instances will be up and running. We can also write docker ps, of course, as usual. See, there's none running right now. The reason why it takes some time to begin with is because now it needs to pull the images. It's pulling the images from Docker Hub, and then after when it's done with that, then it will actually start them up. So it takes some time, especially the first time. Then it will then after that it will be much faster. So now we have 3 replicas of the admin right there. And while we wait, then we can take another command and we can see that we have this Docker info here. And we can see that we are part of the swarm. So we are swarm active right here. Docker info, grab for small, like this. We can also say Docker node. ls again. And then we can see that we have 3 of them running right there. Let's remove this one right here. So it's almost up and running. Let us just write once again right here, stack services. Now we have 10 replicas running, and you also see that we have some of them running locally, and we can also say that we want the Docker node ls. We can list all of the nodes, and then we can say we want the Docker node ps, and then we can say which node that we want to list all of the containers for. And then we have an ID right here. It also has a host name too right here, but it also has an ID right here. So let's ID there. Let us just use ID right here. Maybe we could write 2. Let me just try that. Yes. We can actually just mention the host. That is good enough. Then we can see that we have multiple containers running right there for 2. We can also see that we have some of them are shutting down, and some of them are they do not have the image right now, and that is because we should have set up the registry. We do not set up the Docker Hub registry. There's no such image right here. Can we see that is the error right there? but it's actually running now. So first we got some of them rejected. That's because the image was not available. Then after some time, then we got the image downloaded, and then everything is fine afterwards. So that's actually it. So now we have all of these. Let's also try number 3. Let us try to scale. So first we say Docker stack ls, and then we say Docker stack services. We mention Mike's stack demo like this. And let us try to scale now. So we say Docker service scale, and then we mention Mike's stack demo adminer like this, and then we say equal to. Let's say we just want three replicas instead, then we just write 3 like this, and then 7 of them of course will be stopped. Again, now we can then list services, and then we should actually see that the replicas are going. Right now we have 5 out of 3, and if we repeat this, then at some point we will come down to the 3 replicas. Okay, so now we find out that that node 3, it actually does not want to be a part of the swarm, so we will leave the swarm. Say Docker swarm leave like this, and node left the swarm. So let us see Docker node ls. Let us see what happens now. We can see there's one down right now. This left the system right here. And of course we can also write ps, and then we can list the containers running inside another node. So we'll just write node 2. We still have 2 running right here. And then we have some rejected because of the image which is not available for this worker right here. Yeah, so now we find out that the second node 2, it also leave the swarm. Docker swarm leave. And let's see what happens. Docker node ls. So now we have 2 nodes that are down right now, and then we have 1 that is a leader, that is hostname node 1. So let us try to write the same with node 1. Docker swarm leave, and we know that we need to force, or else we'll get an error. So it is very convenient to use Docker Swarm if you already have, because you probably already have Docker installed. So if you have a Docker engine, then you can definitely just create a swarm out of it, and then you could have high availability for your application, and it's much easier than with the Kubernetes cluster. There's much fewer concepts that you need to learn about. But of course, the Kubernetes cluster has all of these concepts for a reason, because it is actually cool to have your configuration inside the Kubernetes cluster, so it can easily be changed in there, and the same with the secrets. And you can also set up some ingress routing rules. You can also set up some domain certificates inside your Kubernetes cluster. You can set up Nginx ingress routes that matches your application. You can actually have namespaces inside your Kubernetes cluster, which is a kind of is the same as having mini clusters inside the big cluster. That means that the Kubernetes and Docker Swarm cannot really compare them. Docker Swarm is something that you use just to get something up and running right now, and there's no automatic scaling, so you have to scale your application up and down yourself whenever you see that it's needed. And you, of course, you also need to join and leave the workers manually. While with Kubernetes, you can there's a lot more automatic things going on. You can have more pods, as it's called in Kubernetes, spin up when the CPU maximum reaches 80%, for instance. Let us just write docker info and grep swarm right here. And now, we don't have any, when it's not mentioned at all, then it's also because or let me just write it capital S right there, then we find it. That was swarm. Okay, swarm still active. So swarm node ls one not found. Docker swarm node ls docker node ls. That's what I want. So there's actually the client connection is closing. Okay, so it is still part of a swarm because it's it's not done. Stopping the connection. Actually, that's why. So at some point it will write inactive. It's still active a bit, but it is trying to close the connection. So at some point it will say inactive. Try out the Docker Playground. It is cool. It's awesome. Of course, you can also another tip to use the Docker Playground. That is, you can actually open up ports so you can reach them from outside. So if I want to open up a port and say I want to have access to port 8080, then I get this weird URL right here. And right now there's nothing on port 8080. Maybe I should start the admin. So let us just write Docker swarm init. Just again, we will just have one manager this time. Yeah, now I ruined that one. So I'll take node 3 and we'll start a new swarm right here. Docker swarm init. Let us just do that. And then we need to write ---- advertise address, and then we need to say 192.168.0.11 like this. And then we need to copy the Docker swarm file. That's just want to show you that you can expose ports inside the playground. So docker host.yml. Then we paste this, and we do not want 10 replicas, we just want one replica for this, so we'll just say 1. And then we'll say apply. So that's docker deploy right there, copy. So we will deploy now. Stack again. And then we can, after that, then we can open up the port. You will get this weird URL, and then you will have access to the admin. So that's actually it. Use Docker Swarm when you need something that should be lightweight instead of something that's heavy. And just be mindful of this, that you have this Ingress load balancer that will actually take turns in transferring the traffic from either one instance or another instance or another replica of your application. And then set up this Docker registry, so the manager has access to the registry. Then you can then deploy your applications right there. Of course, you can also use some of the Docker registry services out there, like the JFrog Artifactory, and there are many more. I hope you liked this video. If you did, then please take the time to like, subscribe, and hit that notification bell because we have a lot of cool things coming up. Bye.